Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. In this video lecture, we're going to discuss the variance. We are going to define this and learn how to use this, how to calculate the variance for the discrete random variables. So I would like to quickly remind you in the beginning of the lecture what is the expected value and how to calculate this. If you remember, so the expected value of some random variable x is its average value. So what we have to do is we need to find all the outputs of this random variable and multiply them to its corresponding probability, and we have to sum them at the end. So I goes from 1 to the n. So this is how we're going to calculate the expected value. And at the same time, if we need to calculate the expected value of some function of the random variable, for example, x in the square, what we have to do is we need to multiply the xi in the square to their probabilities all the time and sum this from 1 to the n. So I would like to show you quickly a small example. So let's say x is going to take the values like 1 and 2 with the corresponding probabilities 0.6 and 0.4. And if you would like to find the expected value of the x, what you have to do is you need to multiply the 1 to its probability, 2 to its probability, and sum them. So basically it's going to be 1 times 0.6 plus 2 times 0.4. It's going to be 1.4. So if you need to calculate the expected value of some function of the random variable, for example x in the square, what are you going to do is you're going to square only the values of the x, not the probabilities, obviously. It's going to be 1 in the square times 0.6 plus 2 in the square times 0.4. So this is going to be 2.2. So in general, calculation of expected value of the x squared is superbly useful in order to calculate the variance. So we are going to define, first of all, what does it mean, the variance for us. So let's say we are given lots of points, data points there, here, here, and so on. So let me denote them as x1, x2, x3, x4, x5. So what we would like to do is I would like to define a variance as the measurement of the spread of the data set. So the measurement should tell me how much the data set is spread. If the variance is big, it means that the data points are really spread, and if the variance is small, it means that the data points are really concentrated in some point. For example, if your points are given like this, then it means that the variance is big. And for the first set, let's say. For another set, so it is possible that the points are really concentrated in one point or around one point. So in this case, we say that the variance is small. So we would like to define the variance mathematically. So it should give you some numerical value, and you need to use this numerical value in order to conclude whether the points are really spread or they're not spread. And one of the ways to do this would be to find, for example, the mean, which is going to be the expected value, right? So if you remember, the expected value is going to give you the average value of your data set. For example, if you're looking to the data set of the heights of the students or the grades of the students after some exam, the average value is going to be the expected value. So what you're going to do is we need to find the distance between every point, so distance 1, and the mean. So it's going to be the distance 1, distance 2, distance 3, distance 4, distance 5. So basically, we are finding the distances between every point and the mean, and the average value of all of those distances is basically going to mean the variance. We are defining the variance like this. So let us define the variance. So the definition for the variance is going to be the average distance between all the data points and the average value. So if you remember, if you are given some x, if you need to find the average of the x, what you're going to do is you just need to apply this magic function e, so which is going to be the expected value of the x, which gives you the average value of the x. What we have to do is we need to take every value of all the x, right, xi, we need to subtract this from the mean, and if we square this, it is going to mean the distance. So if you remember, for example, if you're given 2 points on the x line, so 1 point here with the coordinates like 3 and 1, so the x coordinate is going to be 3 and y coordinate is 1, and another point was the coordinates 5 and 1. So if you need to find the distance between these 2 points, what you're going to do is you're going to subtract 3 from the 5 and square this, because the distance should be always a positive value, right? So if you would like to find a distance between a point and the average value, you need to subtract the average value from the point and square this, because the distance should be always positive. So this value actually is the distance between xi and the e of x. So between a point and the average value. So average value is the e of x. What we have to do is we need to find the average of all of the distances. Basically, we need to find all the distances, and then we need to find the distances, the average of those distances. And if you remember, if you would like to find the average of something, what you have to do is you need to just apply this magic function e, right? So if you just apply the e, it is going to give you the average of this thing. So basically, you're finding the distance, and then you're going to find the average of the distances. And this is the definition for the variance. So the variance of x is defined as the average distance between all the points and the average value. So obviously, calculating the variance using this formula is not so easy, so we need to figure out another more easier formula. So in order to do this, I'm going to just expand this. So the variance of the x is defined as the expected value of the xi minus e of x. So if you remember, e of x is the average value. It's a constant. It doesn't depend on the x anymore. So then the mu, let's say, in the square. So please note that the e of x is the mu, is the average value. So you can denote the e of x as a mu, and at the same time vice versa, the mu can be denoted as the e of x. In both of the cases, they mean the same thing basically. So I'm going to just open the brackets here. So it's going to be e of, so if you take the square from here, it's going to be xi in the square minus 2 mu xi, right? So plus mu in the square. So if you apply the e to all the terms, you can just apply them linearly to every term. It's going to be the expected value x in the square minus 2 mu expected value of the x, because mu is the constant and 2 is a constant, you can take them out from the expected value, plus the expected value of a constant in the square. So I would like to remind you that the expected value of some constant is going to be simply a constant. So let me explain you why it is like this. So this is just the out of our proof, right? So I'm going to just explain you. So if all the values of your random variable are always a, just one value. So a constant means like you are going to do the probability experiment and you're always going to get a constant. So if I say, hey, what is the average value of all of the sequence? What you have to do is you need to sum them. And for example, there are n appearances of the A. You need to sum them and divide them to the n, and you're going to get again the A, right? So obviously the average of a sequence of ones, for example, is going to be equal to the 1. So that is why whenever you would like to find the average of a constant, it's going to be just a constant. So why I'm saying this? Because the expected value of the mu in the squares is going to be simply mu in the square. So I'm going to write it here. It's going to be e of x squared minus 2 mu times, if you remember, the e of x can be denoted as the mu, right? So times mu plus mu in the square. So you see that 2 mu in the square minus 2 mu in the square plus mu in the square is going to give you minus mu in the square. So I'm going to write this. It's going to be the expected value of the x squared minus 2 mu in the square plus mu in the square. So one of the minuses is going to be cancelled with this, and we're going to have the expected value of the x in the square minus mu in the square. So if you remember, mu and the expected value are equal, so you can denote the mu as the e of x as well. So I'm going to denote the mu as the e of x. It's going to be e of x in the square minus e of x in the square, and this is the variance. So this is the super simplified version of the formula for the variance, and I'm going to memorize this, and we're going to use this in calculations of the variance. So let me denote this with the brackets. Cool. So if you remember in the beginning of the lecture, I wrote a couple of times the expected value of the x in the square, right? So this is the reason why actually we need this formula. So I'm going to use this formula in order to find the expected value when we roll a die. So if you remember exercise, so let's say x is the result of rolling a die, and its distribution function is going to be given as in the following table. It takes the values 1, 2, 3, 4, 5, and 6, and its corresponding probabilities are equal always to 1 over 6. So let's say we need to find the variance of the x. So in order to find the variance, what we have to do is we need to find the expected value of the x squared minus expected value of the x in the square. So let's first of all find the expected value of the x in the square. So just the x, e of x. So in order to do this, what we have to do, we need to multiply the every appearance of the output, xi, to its corresponding probability here. So let's do this. It's going to be 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4, 5, and 6. So if you sum everything, it's going to be 21 over 6 or 3.5, right? So we can just substitute this to here, and we can find this. So at the same time, in order to calculate the variance, we need this term as well. So let's calculate this. The expected value of the x in the square is going to be equal to the summation of the xi in the square times to the probability, right? So just using this table, what I'm going to do is I'm going to take every value for the random variable, square this, and multiply this to its corresponding probability. Please note that the probabilities are not necessarily should be squared, so they are going to be always the same. So no matter what is the function for the x. So in this case, it is the square of the x, but if it would be cube of the x, the probability should be the same. Basically, so I have to multiply 1 in the square, which is going to be 1 to the 1 over 6, plus 2 in the square, which is 4 times 1 over 6, plus 9 times 1 over 6, plus 16 times 1 over 6, plus 25 times 1 over 6, plus 36 1 over 6. It's going to be simply 6, right? Okay, so let me add them. So it's going to be 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided to the 6. So I need a calculator in order to calculate them. It's going to be 1 plus 9, it's 10, plus 20, it's 30, 55, and 91. 91 over 6. So this is the e of x in a square. So we have calculated this as well, so I'm going to substitute this to here. So the variance of the x is going to be 91 over 6 minus 21 over 6 in the square, right? So what I have to do is I'm going to multiply the 91 to the 6 additionally. So in order to get the common denominator, it's going to be 21 in the square, divide this to the 36. So I need a calculator. That's 546 minus 441 divided to the 36. It is 105 divided to the 36. And it's going to be equal to the roughly 2.92. So this is going to be the variance of the random variable x, where x means the result of rolling a die. So in our next lectures, we're going to try to calculate the variance for the other examples as well, and we are going to try to understand the meaning of the variance more deeply.